यस गुड मॉर्निंग स्टूडेंट्स। देखिए हम डिस्कस कर रहे हैं फ्रिक्शन से रिलेटेड प्रॉब्लम्स। यस लिखेंगे प्रॉब्लम, यस लिखेंगे कैलकुलेट अमाउंट ऑफ फ्रिक्शनल फोर्स या फिर मैग्नीट्यूड ऑफ फ्रिक्शनल फोर्स acting on a block for following cases. This is the case. This is a block of 5 kg. Surface is rough. And let's suppose the mu s is 0.3, mu s max and mu k is 0.3. Now, here the force is acting externally, that is 100 of Newton. Right? This is the A part and this is the B part. In fact, आप इसमें calculate amount of frictional force and acceleration of block. The B part is this. This is of 5 kg. This is of 500 Newton. It is still again rough, having mu s is 0.4 and mu k is 0.3. Now, in this case, अगर आप ध्यान से चेक करें तो होगा क्या? सबसे पहले फ्रिक्शन डायरेक्शन कौन सी लगेगी? 5G is acting downward, so it has a tendency to move in downward direction, so friction will act in upward direction. So friction will act in upward direction. Now, how much is the normal reaction there? If we look in this direction, the normal reaction is 100 न्यूटन. अगर नॉर्मल रिएक्शन इसकी 100 न्यूटन है तो मैं देखो क्या बोल सकता हूं, 5G इज डाउनवर्ड, फ्रिक्शन इज अपवर्ड एंड 100 न्यूटन इज दिस, 100 न्यूटन इज दिस फ्रिक्शन नॉर्मल रिएक्शन. तो वी कैन से दिस थिंग. तो व्हाट इज फ्रिक्शन? व्हाट इज मैक्सिमम स्टैटिक फ्रिक्शन? दैट इज म्यू एस मैक्स. That is how much? 40 Newton. And what is this? 50 Newton. So in this case, the maximum static friction, it is less than the value of what? Less than the value of the 50. So it will not remain at rest and it will start moving. And let's suppose it starts moving with some acceleration A. अगर ये A से मूव करता है तो what is the friction? The friction then act is kinetic friction. And what is the value of Fk? That is mu k. What is mu k? 0.3 into Fn is 100. So it is 30 Newton. So this is acting is at 30 Newton. Frictional force. Now it is moving in downward direction. If it is moving in downward direction, so we can write simply कि 5G 50 minus 30, it is equal to 5 into A. So what is A? 4 meter per second square. right? If you look at this part B, now in this case also, the force that is acting in the downward direction is 5G, and normal direction is acting in this direction, Fn. So what is the value of Fn? Newton. Now it has a tendency to move in downward direction, so the friction will act in upward direction. What is the maximum static friction here? Mu s max. What is mu s max? 0.4 into Fn. What is Fn? 500. So it is how much? 200 Newton. Right? The Fs max is 200 and it is only demand is of 5G, 50 Newton. So it will not move. तो यहाँ पर friction जो लगेगा वो Fs लगेगा. And even block is at rest in this case. Block is at rest. Here friction X is 50 Newton. And acceleration is equal to 0. Acceleration is equal to 0. Right? So this is the case for it. Next. A force F is acting P on a body of mass 4 kg या m kg. Calculate minimum and maximum value force so that block remains at rest. This is the case for it. ये है हमारे पास m kg का ब्लॉक. यहाँ पे फ्रिक्शन कोएफिशिएंट इज म्यू. Static friction coefficient. The force is applied in this direction at an angle of theta. Theta. Now, देखो इसमें क्या होगा. The force will have two components. This is F cos theta and this is F sin theta. And normal reaction is acting in this direction. Mg is acting in that direction. And here it is acting the tendency to move. देखो, there are two cases possible. Case 1. If F is small, अगर फोर्स छोटी है तो क्या होगा? Then block has tendency to move in downward direction. And friction acts in upward direction. And friction acts in upward direction. So the friction for the first case will act in upward direction. If the friction will act in upward direction, तो फिर still block is at rest. अगर block rest पे है तो mg is acting downward, friction is acting upward, and this is the force in upward direction. So we can say mg is equal to f sin theta plus small f. And here it is Fn is equal to what? F cos theta. What is friction? Friction is mu into Fn. And Fn is F sin cos theta. So if we take F to be common, so it will become sin theta plus mu cos theta. This is mg. So what is the value of F? mg by F sin theta plus mu cos theta. This is the minimum. Case 2 is what possible? If F is increased, then block will have tendency to move in upward direction. And friction acts downward. अगर ये ऊपर जाने की टेंडेंसी है तो फ्रिक्शन विल एक्ट डाउनवर्ड. दैट इज अ केस पॉसिबल. मैं उसको डॉटेड वे से दिखा रहा हूं. बाद वाला केस है. In this case, there are two forces acting downward and one force is acting upward. Block at rest. तो हम क्या कह सकते हैं? F sin theta is equal to mg plus F. And what is this? F cos theta is Fn. And friction will become mu into Fn. So it will become mu into F cos theta. that will come out this way. mg will become f times sin theta minus mu cos theta. So f will come out to be mg by sin theta minus mu cos theta. This is a minimum one and this is maximum. So if you want to calculate the range, so this is the maximum and minimum, and the block will remain at rest for this range of values of force. Clear? Next you go. Pull is easier than push. जैसे एक केस है पुल का, मतलब एक ब्लॉक है, this is a force acting in this direction at an angle theta, having the coefficient of friction mu, mass is m, and there is a case of push. This is the case of push. F, which is easy to pull and push. देखो कैसे कह सकते हैं. If F is acting in this direction, there are two components of it. One is F cos theta. Another one is F sin theta. And it has a tendency to move in forward direction, so the friction will act in backward direction. Mg will act in downward, and it will act in upward direction. That is how much? Fn. Just calculate the value of Fn first. From the vertical, मैं क्या लिख सकता हूँ? That is mg is equal to Fn plus F sin theta. So what is Fn? Mg minus F sin theta. Calculate in this case. F cos theta is in this direction. F sin theta is in this direction. Mg is acting downward and Fn is acting upward. तो हम क्या बोल सकते हैं? We can say Fn is equal to Mg plus F sin theta. Now what is friction? Mu into Fn. तो it will become mu into mg minus f sin theta, and this is friction is mu into Fn. Fn is mg plus f sin theta. Right? So the friction will be more in the case of push, and if more is the friction, then it is more difficult to move it. अगर मैं इसकी एक्सेलरेशन निकालूं, मान लो इस केस में एक्सेलरेशन निकालता हूं a1, इस केस में निकालता हूं a2. a1 का वैल्यू कितना आएगा? There are two forces are acting this and this. तो a1 will come out to be, that is f cos theta minus f by m. 1 लिख लो इसको चाहे, या 2 लिख लो. What is a2? a2 is equal to f cos theta minus f2 by m. We can easily judge कि f1 is greater than f2 is greater than f1. So अगर f2 f1 से बड़ा है, so a2 is less than a1. Pull is easier. Then push. Right? So we can say this thing directly. Clear है? Next. देखो नेक्स्ट, a body of mass m is placed on a horizontal surface of friction coefficient mu. Friction coefficient mu. At what angle? From horizontal a force is applied at what angle from horizontal a force is applied to just slide a block. At what angle from horizontal a force is applied to just slide a block? and its magnitude is minimum. Its magnitude is minimum. Well, this is the case. And this friction coefficient is mu. At what angle from horizontal the force is applied so that it is in a state of just sliding? It has a tendency to move in forward direction. Friction will act in backward direction. This is the case for just sliding. Block is at rest. So it is moving. We can write कि f cos theta is equal to f, and from the vertical we can write कि fn is equal to, we can write fn plus f sin theta is equal to mg. So what is fn? mg minus f sin theta. And for just sliding, block is at rest. अगर block rest पे है तो we can write f cos theta is equal to small f. That is mu into f. So what is f cos theta? This is mu into fn. Now what is fn? It is mg minus f sin theta. That will become f cos theta plus mu f sin theta is equal to mg. So what is f? F is mg by cos theta plus mu sin theta. Now हम क्या चाहते हैं? The force should be minimum. हम वो एंगल निकालना चाहते हैं जहाँ पे फोर्स क्या हो, मिनिमम हो. तो मैं क्या करूंगा? मैं इस डिनोमिनेटर को मैक्सिमम करूंगा. डिनोमिनेटर क्या हो जहां पर? मैक्सिमम. डिनोमिनेटर क्या हो? मैक्सिमम. अब डिनोमिनेटर को मैक्सिमम देखो कैसे कर सकता हूं मैं इसकी डिफरेंशिएशन ले रहा हूं. डी बाई डी थीटा ऑफ कोस थीटा प्लस म्यू साइन थीटा. इसको जीरो के इक्वल रख रहा हूं. सॉल्व करो इसको, देखो क्या आ रहा है. डिफरेंशिएशन ऑफ कोस थीटा इज माइनस साइन थीटा प्लस म्यू साइन थीटा की डिफरेंशिएशन कॉस थीटा इक्वल टू जीरो. तो व्हाट इज टेन थीटा? दैट इज साइन थीटा इज इक्वल टू म्यू कॉस थीटा. तो व्हाट इज टेन थीटा? इट इज इक्वल टू म्यू. तो इट मींस इट इज मैक्सिमम व्हेन थीटा इज इक्वल टू टेन थीटा इज इक्वल टू म्यू. अगर टेन थीटा म्यू है तो एफ मिनिमम की वैल्यू भी हम निकाल सकते हैं अगर चाहते हैं तो. व्हाट इज एफ मिनिमम? That is mg by cos theta plus mu sin theta. Cos theta. What is tan theta? Tan theta is mu. So it is p upon b. So b is 1. So what is cos theta? 1 upon under root of 1 plus mu square. That is cos theta plus mu sin theta. What is sin theta? Sin theta is mu upon under root of 1 plus mu square. if you will check 1 plus mu square का रूट कैंसल आउट होगा तो what is F minimum? This is mg by under root of 1 plus mu square. This is the value of F minimum, the minimum force to be applied. The minimum force to be applied. Are you getting it? इस तरीके से हम इस क्वेश्चन को सॉल्व करेंगे. Right? Next. Next is angle of repose. It is the maximum angle of inclination of inclined plane so that block placed on it remains at rest. देखो मान लो दिस इज अवर इंक्लाइन प्लेन and a block is placed on it. Theta is the angle. The static friction coefficient is mu s max. Now the forces acting on it is mg sin theta and mg cos theta is acting in this direction and Fn is acting in this direction. Now it has a tendency to move in downward direction. Friction is acting in this. When angle of inclination theta increases, then mg sin theta increases. So friction adjusts itself to keep block at rest. Now we can say at static friction at limiting friction we get mg sin theta is equal to Fn, F, which is mu into Fn, which is mg cos theta. Block at rest. So we will get tan theta is equal to mu s max. तो tan theta is max. तो theta is called angle of repose. इसकी वैल्यू कितनी है? tan inverse of inverse max. Right? So this is called angle of repose. If इसको tan theta नोट बोलो जो इस पे एंगल है. If theta less than theta naught and theta greater than theta naught, block slides. Next less than है तो block at rest. Right? So we can say like this. Is it clear to all of you? लिखें इसको.